Alright, we're in lesson 18. It's about lines and angles. So your first objective is to define different parts of lines. Okay, so first off, a line. Okay, we'll put some points on our line and we'll call them A and C. So a line is something that extends two directions forever. So you'll notice the arrows on the end of our line. Okay, it means it goes to the left forever and to the right forever. It never stops. Now, how do we name a line? Well, we got to put this little symbol. Okay, and we need to put 2 points from the line that are on it. So they give us point A and point C. So we're going to use those. When we name a line, because it never starts and never stops, it just goes on forever both ways, okay, it doesn't matter which way you put the letters. So those two names are the same thing. AC and CA refer to the same line because the line doesn't start, doesn't stop. So it doesn't matter which way we name it. Okay? Array. Array is something that has an end point, okay, and then it goes on forever in one direction. So, this ray starts at A, it goes on forever towards C. The symbol looks like this, just like the ray does. Okay, it points one way. And we always name the ray with the point it starts at. Okay, it's kind of weird they call it an end point when it's actually the point it starts at. But the end point of the ray is A. That has to come first in the name. And it goes on forever towards C. So when you name a ray, okay, if you use the correct symbol, your letter that it points to should always be on the side the arrow is. So notice my C is over here, and that's the direction the ray is heading, is towards C. So this looks like it's heading from A to C. That's what our ray does. Okay, a line segment is part of a line. Okay, a ray is a part of a line, but a line segment is another part of a line. And a line segment starts and stops. Alright? So when we use the symbols can look like this. You can put little dots on the end of them, but you don't need to. This one shows it starts and stops. Okay, and you can name it line segment AC or line segment CA. Okay, the reason we can switch these around is because it doesn't matter if I start at A and go to C. It starts and stops. It's the same length of line. If I start at C and go to A, it's still the same length of line. It doesn't matter which direction I travel. Now the reason why the ray matters is because I start at A and I go towards C and I can keep going and going and going and going. I can't do that if I start at C and go toward A. I don't keep going and going and going. So that's why the direction matters for a ray and not for the other two. Alright, let's move on to a few more definitions. Okay, objective 2 is to define different pairs of lines. Okay, now before we can define different pairs of lines, there's a definition we need to know. A plane. A plane is a flat surface that extends in all directions forever. Okay, so a plane is just like, if you imagine like the ceiling is kind of like a plane. If it could go on forever in every single direction, then the ceiling would be a plane. Same thing with like the carpet. The carpet would be a plane if it went on forever in every direction. Okay, so those are kind of examples. Or a wall would be kind of an example, kind of a real life example of a plane. Just something flat that extends up, down, left, right for all directions forever. Okay? Now, parallel lines are lines that are in the same plane and they never intersect each other. So here is what parallel lines look like. Okay? They have to be in the same plane. So like they would both be on the ceiling of a room, but they never cross each other. So if I drew two lines across the ceiling of the room that never cross each other, those would be parallel lines. Okay, if I drew two lines on the floor of the room that never cross each other, those would be parallel lines. If I drew two lines on the wall that never cross each other, those would be parallel lines. Alright, perpendicular lines are lines in the same plane that intersect at a 90-degree angle. Okay? So they intersect looking like this. And then this little angle, or these angles, all of these angles here, would be 90-degree angles. Right? Every single one of those angles would be 90 degrees when they're perpendicular. So again, that would be like if I drew one line that went sideways and one line that went long ways across the ceiling, and they intersected at a 90-degree angle. Those would be perpendicular lines. And the last definition we need to know is skew. Skew lines are lines in different planes that don't intersect. So parallel lines are lines in the same plane that don't cross each other, like both on the ceiling. Skew lines are lines in different planes that don't intersect. So if I drew a line on the wall and then a line on the ceiling that didn't cross each other, those would be skew. If I drew a line on the ceiling and a line on the carpet that didn't cross each other, those would be skew. Okay, because they're in different planes. Alright, let's move on to some examples here. Okay, the next thing we need to know is how to, we're going to talk about pairs of angles and how to name angles, parts of angles and how to name angles. Okay, so when I talk about an angle, I'm talking about this little space right in there. What an angle is it's something that's formed by two rays, okay, where two rays meet together. So here's ray BA, it starts at B and goes forever toward A. And here's ray BC, starts at B and goes forever toward C. Those two angles meet at this same spot right here, or those two rays meet at the same spot to form an angle. Okay? And you need to know what that point is called. When the point, or the middle point of an angle, the point where the rays meet, that's called the vertex of the angle. Okay, you're going to see that word vertex a lot. It has some different meanings, but for an angle, it's the point where the two rays meet. We also need to know how to name an angle. Okay, now there are good ways and bad ways to name angles. I'm going to show you the good ways, of course, because all you need to know is the good ways. First thing you always need to do is put the angle symbol. Now, you should always name an angle as specifically as possible, meaning the more letters you use, the better. Okay? So, there are 3 letters on this angle, A, B, and C. You should use all 3 of them when you name this angle. Okay? And the way you always name those, the only thing important, it doesn't matter which letter you start with, as long as this vertex is the middle letter. So you don't start with B, okay, we don't say BAC, but you can start with either of the other two. So let's say I start with A. Then B needs to be the middle letter, and C needs to be the last one. And if I've done this correctly, I should be able to trace my angle with those 3 letters. So if I'm at A, I should be able to trace B to C, and that should make my angle, A to B to C. Notice how if I started with B, it went B, A, C, all of a sudden this right here, this isn't part of my angle. There's no line there to connect. Okay? So BAC doesn't work. The only other way I can make this angle is to go from C to B to A. So I can make this angle CBA. Those are the 2 best ways to name the angle. Okay? Sometimes you'll see an angle named with just the vertex, so it'd say angle B. The only problem is that's not quite as specific because you'll see some instances where there might be more than one angle B. And we'll talk about those later. Sometimes you might see an angle named angle 1 or angle 2 as well. But these 2 up here, these are the best ways to name angles if you can. Alright, let's move on to another slide. Okay, objective 3 is to define types of angles and measure angles. So let's first define types of angles. First type of angle you need to know is acute. Acute angle is less than 90 degrees. Acute angles look like they're kind of closing their mouths. Okay, now they can be a little bit closed, they can be a lot closed. Okay, but they look like they're closing up. So here's our acute angles. They're cute little guys, less than 90 degrees. And then a right angle is exactly 90 degrees. A right angle is formed by one ray that's straight up and down and the other that's straight to the side. Okay? Now you will always be able to tell that's 90 degrees if it's got a little box there. That little box says that it's 90 degrees. Obtuse is a little more specific of a definition. Obtuse is more than 90 degrees but less than 180. Obtuse angles look like they are opening mouths. Okay, so they're bigger. Now they can be kind of big, or they can be really big. Okay, like a big old yawn right here. Really tired in the morning, your mouth's way open. That's like an obtuse angle. A straight angle is exactly 180 degrees, so it's just like it sounds. It's straight. It's a straight line. 180 degree angle. And the last thing we need to know is a pair of angles. Okay. One pair of angles you need to know is called a linear pair. or supplementary. It's just like it sounds. Linear pair means it forms a straight line. But it's two angles together that form a straight line. So this right now is just one angle, but if I put another ray in here, all of a sudden I've made two angles. Okay, we can put some letters with it. A, B, C, and D. So I got two angles right here. There's one, and here's the other. Those two angles together form a straight line. So those have to add up to 180 degrees because a straight angle is 180 degrees. So, if I were to name these angles, angle ABC plus angle CBD has to equal 180 degrees. Okay, so the measures of those angles have to equal 180 degrees. Speaking of measuring angles, let's talk about how to measure some angles. Okay, the last thing we need to know is how to measure an angle. Okay, so the steps over here. The first thing you need to do is determine which way the bottom ray points. So the bottom ray here points to the right. Okay, that's the first thing we need to know. Now step 2 says if it points to the left, you read the angle using the inside numbers. So if it pointed this way, then we would read the angles using these inside numbers. Well, since the bottom ray points to the right, okay, step 3 says we need to read using the outside numbers. So what we're going to do is we're going to start down here at the bottom of the ray and read the outside numbers, and we're going to go just until we get to where the other ray crosses it. So we're going to start at the bottom, go to where the other ray crosses it, and we're going to read the inside number here. That is 50. So the measure of angle RST is 50 degrees. Got to make sure we put degrees on there. Okay. Now let's say Mr. Ayers decided that he wanted to draw another angle. And let's say I'm going to put the letter V here. Now I said let's find the measure of angle VSR. Oops, not VRS, sorry. Should probably name it correctly, huh? VSR. Well, now the bottom ray points to the left. So now we need to read the inside numbers. So I'm going to go all the way around here from the left. So I go from the bottom ray, go all the way around, and see where it crosses. And now I'm going to read the inside number. This time the inside number says 130. Well, these should make sense because look at angle RST. Look at this one right here. What type of angle is that? It's closing up on itself. It's a cute little guy. This is an acute angle. Acute angles need to be less than 90 degrees. So if we read this as 130, we know that's wrong because it's an acute angle. It's got to be less than 90. So 50 is the only right answer. Now look at angle VSR. It looks like it's opening up, which means it's obtuse. So when we look at where these cross, it can't be 50 degrees because obtuse angles are more than 90. So it's got to be 130. Alright? Okay, good luck on your homework.